Supplemental math videos from Circle Christian School. Using more two-column proofs in geometry, thus giving you more and more geometry. Let's begin with some basic theorems that we learned in the lesson that we had today. Theorem 2.3 is called the right angle congruency theorem. Notice that I'm using some abbreviations or some symbols, and it's okay to use some symbols as you work, just as long as you use some proper symbols. The right angle congruency theorem. Basically, it says all right angles equal each other. Theorem 2.4 is the supplementary addition angle. That if one angle is supplementary to another angle, and another angle is the same size as the first one, then it is also supplementary to the other. This is a lot like that addition property that we had, where if A equals B, then A plus C equals equals, let me get my white out, equals B plus C. The next one after that is theorem 2.5, which uses complementary angles, and it has the same process going on as the supplementary angles, that if one angle is complementary to another angle, then another angle that is the same size as the first will also be complementary to that angle. And again, it's got that same thing going on. If A equals B, then A plus C equals B plus C. And really what you're looking at here is that if this guy and this guy is the same, the A's and the B's, then if you add the same thing to both of them, then they have to be the same. Postulate number 12 is just kind of a fun, nice one. It's called postulate number 12, but basically it is the linear pair postulate, and we talked about linear pairs. That's the thing that you're going to lose the most. But basically, if you have a pair of angles on a line, angle 1 and angle 2, then angle 1 plus angle 2 equals 180 degrees and are a linear pair. And theorem 2.6 is the vertical angle theorem, which we also proved earlier. And that says that angles that are opposite each other are congruent to each other. And when they're side by side, like from here to here, then they're a linear pair, which means they equal 180 degrees. All right, a little bit of a test. Which equation can be used to go find x? When we do our geometry, remember that you're always supposed to draw a picture, that you're supposed to add your labels, and then you look for geometry discoveries. So that's what I'm going to do first, is look for some geometry discoveries, because then we can do the algebra. So first I'm going to take a look and kind of see, how many angles that I have going on. And we have 1, 2, 3, 4, which also have straight line angles, and there's 4 of those. And you'll remember that we have 8 angles altogether. Now the next discovery that I'm going to make is that we have linear pairs that are 2 angles that when they're side by side equal 180 degrees. And we also have vertical angles, angles that are opposite to each other, and they're congruent. to each other? Well, our discovery here is that we have two angles that are next to each other, so we know we have a linear pair. That means if we add them together, they should equal 180 degrees. Now I'm going to look for a statement that matches that. And going through A and B and C and D, C would be the vertical angles, and we already know they're not vertical angles. Really don't see anything about 212, so we can cancel that one out. So now we've got possibilities of A and B. This is how you solve kind of an A, B, C, D problem. Eliminate what you know isn't true, and it's a little bit easier to pick from the other two. Well, we also know that a linear pair, or two things on a line, don't equal 90 degrees. We don't see anything that is complementary. These are complementary. So therefore, our final answer is going to be right here at B. Good job, guys. Another good example of using the geometry discoveries of supplementary, complementary, linear pair, vertical angles is the example that we have here. We have several things going on. So with our geometry discoveries, we know that we have some linear pairs, and those when added together equal 180 degrees, and we know we've got some vertical angles. And again, I'm going to use a little bit of a symbolism here just to shorten some things down, and linear pairs are congruent to each other. So what we want to do is figure out what's going to be a good setup with our different variables. Now we have a y at the first angle here, we have an x, then we have a y, and then we have an x. Well, doing the linear pair thing results in having little x's and y's being added together to equal 180. And having the two different variables can be a little bit daunting. However, if we take a look at what happens with our vertical angles, we'll see that we have same variables, an 8x and a 9x, and we can use the property of vertical angles that they're congruent, and if they're congruent, then they're equal to each other. So 8x plus the 7 is going to equal the 9x minus the 4. And I'm just going to go and walk through a little bit of our 3 steps in the kingdom of pi for solving an algebraic equation. Make sure we start with offensive equality. The first step, step 1, is to see if there isn't anything that needs to be distributed or combined on either side of the fence. There is none. Only have 2 things on one side, a variable and a constant number, a variable and a constant number. Very good. I can move on to step 2. Step 2 says isolate the variable using the additive inverse. I like to get my variables by itself. I like my variables on this side of the equation. So we're going to take away the 7, and we're going to take away the 7. And now we're just going to do the work. I like doing my work vertically, making sure that I do variables to variables, constant numbers to constant numbers. And then we just bring everything down. We do the math. So we have 8x. The 7's cancel out. Leaves us with a 9x and a negative 4 plus a negative 7. It's a negative 11. So watch your integers here. The next thing is I'm going to get a constant number by itself over here, which means we're going to move the variables off to the other side, off to the left-hand side here. So I'm going to minus the 9. It's just an opposite sign and an opposite sign. I'm going to do the math. So 8x take away a 9x. That is 8 take away 9. So think about it on a number line. 8. I'm going to jump back to 0. That's 8. And one more takes me to a negative 1. It's okay to write it as a negative 1x, or you can write it as a negative x. The 9s are going to say goodbye. It gives me a negative 11. And we're going to divide by 1, negative 1, and divide by a negative 1. Step 3, isolate the variable using the multiplicative inverse. And we find that x is going to equal a positive 11. Anytime I get an answer, I like to circle it, so I know what x is here, because you never know if I'm going to have to use it to actually find the degrees of something. So now I have to go find the y's. And remembering again that we have some good vertical angles here. Vertical angles are congruent, so we can let them equal each other. Start with my fence of equality. All right. Now note that we have a variable on one side of the fence and a variable on the other side of the fence, but only one constant number here. And generally I like to have all my variables over on this side. Doesn't mean you have to, but I like doing that. And I like to have my constant numbers over on this side. So I'm going to take the 7 away from my 7y. So opposite signs, one's positive here, the other's negative. I'm going to take away 7 here. And now we are going to go ahead and do the math. So 5 take away 7. And again, you could think of a number line. I'm at 5, 4, 3, 2, 1, 0. That's 5 of them going backwards. And I have to go back 2 more, so it's going to be a negative answer. The big number always carries the sign. So that's going to take us to a negative 2. Another way to look at this is, you know, signs first, math second. And since the big number carries the sign, I know it's going to be a negative. And then just walk backwards. You can go 7, take away the 5. Okay, that leaves me with the 2. Don't be afraid of those integers. Conquer them. And that a negative 2y, my bad. Because a y, take away a y, leaves you with a y. And a negative 34. And now we're going to go step 3, isolate the variable using the multiplicative inverse. The negative 2 being multiplied to the y means that I'm going to divide by the negative 2. So I'm going to divide by the negative 2, the opposite of multiplying, and divide by a negative 2. These cancel out the negative 2's here. Any number over itself equals 1, which is the multiplicative identity number. So I get 1 equals negative negative means I'm going to have a positive answer. 34 divided by 2 is 17. And now we have x and y. And if for any reason the question was, where's my purple? I was looking for purple. What if they happen to add to the question here, what is the measure of each angle? Because we have both our x and y now, we can plug it back in and find out what the result is. So because x is 11, I can go 8 times the 11 plus the 7, which would give me 88 plus 7, or 95 degrees here. Double check it down here. So 9 times the 11 is 99. Take away the 4, and 99 take away 4 is also 95. Very good. Works within the properties of vertical angles here. Can also do the y's. We know that y equals 17. So what we have here is 5 times the 17. Try a little bit of math. 5 times the 7 is 5. 35. Carry the 3. Little guys right here. Equals 15. Not 15. My bad. 3, 5, 85. Oh, silly me. My brain's going crazy here. So that's an 85. And then we can put it back into this one. So we have the 7 and the 17. It's a bad 7. Minus the 34. And again, 7 times 7 is 49, and 4 is 119, minus 34. Should give us an 85 also. Very good. So far so good. I have congruent vertical angles. And then we can always double check this at this time, because we know we have linear pairs here. Linear pairs equal 180 degrees. So we can go 95 plus the 85. Does it equal 180? And once you've done the math, you say yes, and all is good in Geometryville. All right, guys, have an awesome weekend, and try to be linear. So how many degrees will you be?